Hi, it's Adam. As mentioned in the Facebook post, I'm going to be speaking English for this. If you have any questions about something I've said, you can just ask, and I can probably explain it in Norwegian. But for speeding this up, it's easier for me to explain it in English. So we're going to start off with Oppgave 8, and then it's part A. You can do it with the disk method or the shell method, but I'm going to be first now showing the disk method. So I'll just mark that disk method. So whenever you're doing these volumes of a function, it's always easier if you draw it out. Remember, f of x equals x squared. So that function is going to look like this. And we are going to go from x equals 1 to x equals 3. So this whole area here is going to be the actual shape that's going to be taken around the x-axis. And we're going to end up with a sort of volcano shape, a solid volcano. I'm not very good at drawing, but that's a volcano. So if we think about this, what we're trying to do is, if this was taken around, it looks something like that, between this point and that point, top of the volcano, bottom of the volcano, and we are going to take these disks, and then you're going to take the total volume of that little tiny slice of disk, but the sum of all of those from 1 to 3. So this disk, we're trying to find the volume. If you were going to find the area, if we took a disk, it's a circle, what's the surface area of this circle? That would be pi r squared. The surface area of any circle is always pi r squared. So we're going to say that the volume is equal to pi r squared. But remember, we also have a thickness here, because we're going to find a volume, not just the area. So that thickness is an infinitely small cut to make that disk. We could call that delta x as a change in x from here, from one side of the disk to the other side. But since that's infinitely small, we can change delta x to dx. So I'm going to take times the height. That would give us volume. But then we need to find out what the radius is and what the height is. As mentioned, the height is just the thickness of this disk, which is an infinitely small slice, which makes it dx. The change in x when it's infinitely small. And the radius is going to be from the x-axis up to the function. So that means that the function is, of course, equal to y. So this really is then going to be the function of x. Y is equal to the function of x, which is then equal to x squared. So when you put both of them, or put all this together, you get that the volume is equal to pi times radius squared, x squared squared, times the height, which is dx. We simplify that, and it becomes pi x to the fourth dx. Now, remember, this is for one slice, but we want all the slices from 1 to 3. That would be the sum of all of those. And when we're taking, when we want the sum of something, we can take the integral of it. That's really why it looks like an S, is because it's the sum of everything on this side. So now we have that the volume equals pi times the sum of all of those volumes from the disks. So now all we have to do is integrate 4x. I'll take that over here. So v is equal to pi, put this in brackets, we take x to the 5th, divide everything by 5, so it's 1/5. And then we need, remember this is for one disk, we need to find from 1 to 3. So I'll take 1 and 3 and 1 and 3. So now that we have this, this is going to give us our total volume. We just solve for that. That becomes V is equal to pi times, what is that? That would be 243 over 5. If you plugged in the 3, it's, you know, x to the 5th, or this would be 3 to the 5th. It's 243, and then divided by 5. But then you're going to subtract the 1 value of this. 1 to the 5th is 1 times 1 over 5 is then just 1 over 5. This is easy math. Somebody's probably noticed that I don't use a c. There's really no point in using the c because that's going to disappear in these. V equals pi times 242 divided by 5. And that's it. You know, it's just 241 minus 1 is 242. And that's your volume of that, of this volcano-looking thing with the disk method.